This is TK Academy, Team Knowledge for Architects and Designers. This session is from our Technology Forum, which is the discussion of the technology and tools and how we use them within the industry. And the session we are covering today is Revit. First, you should be aware of that there is a national BIM standard. This is produced by the National Institutes of Building Sciences. This particular one you're looking at is version 3, which is published in 2015. And this is a monster of a document. This particular version has over 2,200 pages, and it contains a lot of tables and charts and graphs. And so this is something that you can either find extremely boring or extremely overwhelming. It's not light reading, but there is some really good useful information in here. One I'd like to point out is this table 21 elements. Elements is just another name for families which are used in modeling in Revit. There's some basic information here, but then it gets into this particular table, which is organized by uniformat. If you're familiar with that, it's published by CSI and it's used frequently in developing cost estimates. And so the level 1 is your main categories. So the first one we're looking at here is level 1 is substructure, your foundations. And then level 2 gets into more detail, level 3 more, and finally level 4 to the highest level of detail. After substructure, our next major category, highlighted here in yellow, is your building shell. And then you go down to building interiors and then building systems and so on. So the National BIM standard has all this information, and what we need to do is get what is relevant and important for your particular use. And so it is recommended that every office or every practice has a BIM execution plan. Not only every practice, but every project has one specifically made and tailored for it. So the BIM execution plan, again, there should be like an office level, which here you can see from our table of contents, the first several sections are all basic generic information or non-specific that apply to the entire practice. And then the later on sections here, section F, G, and H, the modeling plan, analysis plan, collaboration plan. This gets into the specific needs and purposes of the project and how this model is going to be used. Underneath the modeling plan, we have the minimum modeling matrix, the M3. And this is really the heart of the BIM execution plan. What is also very important are these process maps, which we include as the appendix. This is a graphical depiction of how each process is going to flow during the development of the project. Now, as I indicated, the heart of this is really the minimum modeling matrix, and this is just a blank form that we have in there. This was developed largely by the U.S. Army Corps of Engineers with input from the private industry. And why this is important is it essentially says what is going to be modeled and what level of detail is it going to be modeled to, and who is responsible for modeling it. And so we've actually taken that, we've developed this into an Excel spreadsheet, which we found much more useful for filling out and completing. So this is again organized by the uniformat. It's based off of the table 21 that I showed you from the National BIM standard. At the bottom here, you can see the different tabs. These are the level 1 categories. So we have the substructure, shell, interior, services, equipment furnishings, special construction demo, and site work. So each one of those major categories has its own sheet. And then the levels are indicated on this far left column, and then the element's name, the OmniClass ID, and then the uniformat ID. And this is rather important because the uniformat ID is the same as the family assembly code within Revit. Sometimes there is an associated master format section with those. And then we have our first column here, which is in red text, the project scope requirements. And so this is where we need to make a decision or a judgment on whether or not this is part of the project or not. So for example, we're looking at foundations here. Most buildings have foundations, but if we're doing a renovation project, we're not going to be modeling the foundations. So we have a drop-down menu. It's either yes or no. Either it's within the project scope or it's not within the project scope. If it is in the project scope, it already has an assigned level of development, LOD. And this is not something that we get to decide. It's pretty much dictated that if we're going to be modeling it, that's the level of detail we're going to be modeling it to, as well as the grades for the model. We have for the design model and then for the record or as-built model. And then finally, again, in the far right column, in red text, design authoring disciplines. So we have to assign this responsibility to someone within the team, and we have a team with abbreviations listed up on top for reference. So just for example, foundations, let's say, yes, we do have foundations in here, and we know that's going to be our structural engineer who's going to be modeling it. Okay, and then standard foundations, yes, again, the structural engineer is going to be modeling it. But then I'm going to just kind of skip a couple levels here to special foundations. This is going to be a no. We don't have anything special in here. And what's nice about having an Excel spreadsheet, I have these rules written in that when we say no, it just strikes out that entire row so that we know that it's not going to be within the project. There's no mix-up then of what might be mistaken as being within the project. It strikes that out. So if it's yes, it just leaves it, keeps it remained and highlighted in there. But then if it's a no, it's struck out. But again, we have to also then figure out if it is in the project, who's going to be modeling it. And this is pretty self-explanatory when we're talking about substructure. It's usually the structural engineer, but there are some certain cases for other things, especially when we talk about like the building shell or the building interiors, who needs to be responsible for modeling that. And so that's why this is pretty important, that it lays all that information out from the very beginning of the project. Getting into the Revit software now, it is recommended that you spend time producing a Revit template. And Revit, if you've worked with it any time, you know that there is a new version that is released every year, and it is only compatible with like versions. And so everyone has to be on the same version. And one thing we've done is made it a habit that every time a new version of Revit comes out is when we also update our template. And so that is seen here in this project starting view down in the bottom right corner. We indicate what version the template it is that corresponds with the year. Another thing that is recommended, as you saw right from the beginning, is that we have this project starting view, and we have this set up so that when you close the software and then reopen it, it will automatically come to this screen first. So this is a good information for the entire team to have. Obviously, we got our project information in here, the project name, location, and other specific information regarding the project. And then we also have the project team, so you know who is working on the model, who is responsible, and who's all involved based upon all these different disciplines that are part of the project. And then we have a box over here for the Messenger Center, which is a nice place for the BIM manager to leave specific messages for the entire team, so everyone sees them when they first open up their Revit software. On this top left corner is information about the project browser. And so we organize all of our sheets by discipline, and we do it by assigning a view classification parameter. And so all these drawing sheets will appear in this order, and therefore also on our sheet index, all the drawings will populate in this order based upon that view classification parameter. The project browser is something that can be customized and created to your own standards. So over here in the bottom left corner, you see the project browser. These are categories that Revit automatically assigns, but then within there you can create your own organization. So within views, we have architecture, general, and interiors. Those are our disciplines other than landscaping, which is not something we really do much in Revit. That is still mostly a CAD platform. But we have these different views in here that are populated, and these are all pre-assigned. So when you open up the template, these are already here and in place. And if we take a look at the floor plan, you can see that we've got the exterior elevation tags are positioned, and so our working plane is within that space. If it all fits. Obviously, if it's bigger, we'll have to make some modifications. But as long as you're working, you can start modeling right away within this space, and we know that it's going to fit on the sheet, border sheet that we've set up at an 1/8" scale. Now, the drafting views in here. This is something that we've done. We've gone to a great extent and put a lot of details in here. We put all of our standard details in here before we have them loaded. So when you open this, all these are already in here, such as that. So you don't have to spend time drawing or importing. All these are already here, and they can just easily be placed on the drawing. Now, there's always some discussion about how much information do you put in your Revit template. You see that we've taken the position of putting a lot, especially when it comes to details, because this drawing details, this is really just two-dimensional line work here and does not consume a whole lot of memory. It's really families that take up a lot of space. So we preload a lot of these details here to make it a whole lot easier for someone who may be new, or well, actually for anybody to be able to have this information readily available and at their fingertips. They don't have to go searching or recreating it. But when it comes to families do take up a lot of space, and so we tend to keep those external in a different library that can be imported in when necessary. So going back to our project browser, that's architectural. We have the same for interiors. We have all these drafting views, all these base cabinet, all these cabinets and signage, all of which are preloaded into our Revit model. The next category is legends, and again, same thing. We've got all these pre-established in here, so they are readily and available. Schedules, which can sometimes take quite a while to get them to working functionally with your elements, and so all these are already created and placed within our Revit template. Just open up one there. There's, for example, for our door schedules. And then the big one here is really sheets. We have all of our drawing sheets set up in here. They're different disciplines. This 0 is actually our project starting view of the first sheet that I showed you, just to keep it separate from everything else. It really doesn't belong in a discipline category. A is our architectural sheets, G, general sheets, and I, interiors. So within architectural, all these are already pre-named, and they come in the proper order. So you can just open up one of these, and the information from our legends and everything else is pre-populated within here, with also our title block family. So we have these for all different disciplines. We do have what I call additive sheets. So for the first floor plan, an additive is basically a blank sheet. When we open it up, you can see here there's nothing on it. This view is already placed on the sheet. So going back to this earlier floor plan, you start modeling in here, it's already positioned on the sheet, so everything will automatically populate. But this is an additive sheet. There's nothing on the sheet right now until you start drawing or placing it. And then we have what I call deductive sheets, which would be a sheet that is already pre-populated. Since we have all of our details already preloaded into the Revit template, we also have these sheets pre-populated with all these details placed on it This one is in particular is low slope roof details. And we do this because it's easier to subtract than it is to add. It's very easy to go in here and just hit delete and make the details that are not applicable just disappear. And they're still within the template, they're just no longer on the sheet. And so we can create a sheet very quickly using that method. So that's what I call a deductive sheet. Most of our details are set up that way to be deductive in nature. They're pre-populated with the information on there, and you just subtract what you need. And obviously if there's some custom details, then you have to create those and put those on the sheet. With our schedules, again, we have the schedules pre-created, and so for like door schedule, you see here that it's there, since we don't have any doors modeled yet, that none of the information is there. But as you start to create doors in your model, this will begin to self-populate and fill up the sheet, as well with all the details, door frames, elevations, and details in here that can just simply be deleted or moved around, manipulated as necessary for the project. And just to show some for interiors too, as we expand this out, casework tends to be one where we have a lot of information on. So in this case, if we bring up the casework details, this is an additive sheet, and so there's no information on it. We do have on our title blocks grids which help position their details on the sheet. But then going back to our views, with all the drafting views already there, again, it's very easy to just take these and just drag them to where we need to on the sheet, and be able to populate something very quickly. Again, this is just all based within our template, so it all is able to be populated very quickly on a drawing sheet. So the focus here is to twofold, is to build up efficiency, and also more importantly for quality control, so that we have everyone working off the same set of standards and doing things the same way. Let's go close this now, and we're going to go to our final category here in our project browser, which is families. And so you see these different categories that are identified here. These are defined by Revit. We don't get to define what these are, but in a broader sense, there are two types of families. There are the systems families and component families. So system families consist of ceilings, floors, roofs, stairs, and walls. Component families would be things such as casework, doors, furniture, generic specialty equipment, and windows. And so if it is a systems family, we tend to include that in our template. And component families we put outside of our template. They're not as used as often, and it's a way to kind of try to keep our template size a little bit smaller. So within all these families down here, I'm going to go toward the bottom here, and we're going to look at walls. And so walls, again, is a systems family. You have your basic wall, curtain wall, and stacked walls. Those are defined by Revit. But within these, you are able to create copies and manipulate new systems families. And so underneath basic wall, we have some standards here for exterior walls, grade beams, which we technically call basic wall, and our interior partitions. And we have about 150 standard interior partitions, and they are all listed here. They're all coded. So if you know the code, you understand what these walls, these interior partitions are. Another example of what we preload as a family is going to be our profiles. And so as I expand this, you can see gutter profiles, these different styles, and these are styles that are defined by SMACNA. So if we open up one of these, so when you open up one of these profiles, families. You can see the standard shape and what dimensions you're able to plug in there, and these families do change based upon the dimensions that are put in there. So you can size your gutter and it will automatically size as needed based upon that profile shape. So with families, since we do keep all our component families external in the library, just want to show you how we organize that here. So this is we have a Revit file in here, a Revit folder for our templates. And so you can see we have families, materials, patterns, templates. Up here in families, I'm going to expand this, and here are categories again defined by uniformat. And so we have those broader categories, those level 1 categories defined there. And then as you open this up, again following uniformat, let's take a look at exterior enclosures, for example windows. And so those are some of the examples of how we categorize component families within our library. Another example, let's back out here, equipment and furnishings, equipment, and so here are some of our equipment, our lockers and toilet accessories that we have as component families that can be loaded into our model when necessary. But these do not exist within the template. They reside in the library outside and are imported on an as-need basis. A couple other things I wanted to demonstrate real quick within our template is some of the graphic conventions that we have built into our template. So I'm just going to open up this sheet for reference. You can see some of our standard architectural hash patterns that we have up here. This is pretty conventional. A lot of firms have this, but what we've done is within our fill regions, we've imported or created all these, here you can see all these standard hatch patterns into our template. And so these are consistent whether we were doing a Revit project or an AutoCAD project. These are the same standard templates that we use as a graphic convention. Same could be said about line styles. I'm going to drop this down. I'm going to start off on the bottom of this scroll list, and so these are some of the typical line styles that we use in Revit: thick lines, thin lines, wide lines. Up here is medium lines. But you also see some of these that are capitalized, and these are standard layers that you would expect to see in AutoCAD. And so we have these set up. They match the same type of line properties that would be in AutoCAD. And so whether we are importing or exporting things from Revit into CAD or AutoCAD into Revit, we have some standardization in these line types that they come in at the same weight and style. So again, the ones that are lowercase are ones that are primarily Revit lines, and then the ones that are capitalized are also available to be used in Revit, but are really there more for when we are importing drawings in from a different platform such as CAD. The final convention I wanted to just point out here was the text. We do have these preloaded in here as well. These are our authorized text styles that we have as a graphic convention. So you can pick from one of these. There will always be occasions where you may need to pick something else, but these match most of our standards that have been developed in the firm, and these can be used on any of our Revit drawings. Next, we're going to go over keynotes, and so I'm going to go to the viewpoint for a floor plan. And in order for keynotes to work, we have to have a couple of elements actually in here. So I'm just going to randomly draw just a couple of basic walls, just to give it a couple objects to work on. So we use user keynotes, going up to here, dropping down to user keynotes, And what is great about this is, we'll plug this in here, is once we establish the keynotes here, you see this pop-up window come up, and these are the keynotes that we have preloaded into our template. As you can tell over here, that these are organized by master format with no master specifications. So you can drop this down. I'm just going to pick one here, Division 6 rough carpentry. I can expand that down, and you know, you can keep drilling down depending upon what you are looking for here. So underneath miscellaneous rough carpentry, here we actually have the size of the wooden frame member. So I can pick whatever I want that to be, a 2x6 for example, and that keynote will automatically populate. And you just see it here with the keynote, but now so if we flip over to the first floor plan over in the keynotes, and you can see that this has already been brought in because the viewport or the view is already positioned on the sheet, and the keynotes, here it is, that keynote, the 2x6 is automatically populated in there. So just to do a couple more here, just to show how this works, again, we go up to annotate, keynotes, user keynotes, the pop-up menu will show up here once we drop our keynote in. Here we go. And then this is just a matter of navigating to whatever item it is that we want to keynote this as. So I'm going to do something different this time. We're going to say windows, and it's a metal window, aluminum window, casement window. So I can just plug that in there, and you see that this again now populates as number 2. It's the second keynote on the page. Flipping back to the first floor plan on A101, and you can see that that keynote has automatically populated on the top of the sheet again. So I'll just do one more just to show how this works. So I still have the keynote feature activated, so it's going to come up here again. This time I'm going to say it's masonry, unit masonry, concrete unit masonry. It's a split face CMU. I'll just plug that in there, and pow, it just pops up. Number 3, the third keynote, and again on the sheet A101, which that view is put on, there it is, split face CMU. So the keynoting is made very easy through the standard. We have a lot of keynotes that are pre-populated in there, and then as there are custom features, you have to add to the keynote list and re-import the list back into the project file for that to customization to take place. Okay, just a couple more things here that are a little bit more automated. So the keynotes, you actually had to tell it what that item was that you were trying to note. Since we have interior wall types that I drew in here, I'm going to show this. That again, this is a family that's preloaded in there, so we were able to get the information that we want all in that family. And so now when I go to tag it, it automatically tags it with that wall type. So this is a wall 3BEN. And I actually drew 2 different walls here when I put these on, so I can show you the other one. Again, this just drops in 3EBN. So we have 2 different wall types. I do not have to tell it that. It's already in the family type parameters, and so all it is a matter of just tagging by category and clicking on that, and it's automatically going to identify what that wall is. Another part that's automated in here, and this probably not be any surprise to anyone who's familiar with Revit, is your doors and door schedules. So we obviously have door information in here, and you can plop those in on your wall, and also tag those the same way through annotate, tag by category, and it drops our door tag in there, which, you know, we'll change this to 1 since that's our first door. I don't like leader lines on my door, so I'm going to get rid of that and just place this in here. Okay, and then we still have our doors and frames open up on page A601. So as I zoom in here, now you can see that that door information has already been populated in the schedule. So as we as we have in our template a lot of these system components, we've already developed a lot of these. You can see this as I drop down these different family types, the different types of doors that we have already established within our model, and with that information embedded within its properties. So it's makes it very efficient to be able to, when we're laying out a space, be able to label and note our wall types, doors, and using our user keynotes to be able to very quickly document a set of architectural documents. So one final thing to cover that will bring this back to the beginning and wrap this up. When we're talking about the national BIM standard and the minimum modeling matrix, I pointed out the unit format number, and I said that that was pretty key because that's also the assembly code in families. And so I'm going to take this back to families here. I'm going to open up one of our exterior wall types, and this should not be new to anybody who's worked in Revit. You see the example over, or preview over on the side, and then the properties. And when I scroll down to identity data, here you see it right here, the assembly code, and then this number plugged in. And if you click on that, it brings this up, and it's already shows you what is defined in there, but I'm going to just bring this down. So this should look familiar. This is the start of the unit format system at the level 1, and then level 2 in this case would be B20 exterior enclosures, level 3 B2010, and level 4, so on. So you have to be able to define what this assembly code is in here. Now when we create families, that is one of the requirements. Every family has this assembly code assigned to it. Now why is the assembly code important in Revit? Because that is what enables the information transfer to occur between Revit and other platforms. So if you were doing a system that was doing specification writing, which is common, where it pulls the information from the Revit model, or for quantification for a cost estimate, it pulls the information from the BIM model. Well, where it gets that information from is the assembly code. So families have to have the proper assembly codes listed in there for the information transfer to occur with other platforms. So that is something that is built into all of our families, whether it's a system family or component family. We have all those assembly codes that are built into those. This completes our TK Academy course over Revit. Thank you for participating in TK Academy. Please give this video a thumbs up, or feel free to leave a comment. You can also subscribe to TK Architecture on YouTube for additional videos and courses.